morning, everyone. Today we will going to discuss an important experiment wherein you will going to determine the iron content in the given sample by redox titration using external indicator. Firstly, one should know what all the reagents required for this experiment. Number one, freshly prepared more salt. Number two, potassium dichromate solution. Number three, sulfuric acid. Number four, potassium ferricyanide, that is an external indicator. So far, you have determined to total hardness of water by EDTA method. You have determined total alkalinity of water. You have determined chloride content in the argentometric titration. You have determined available chlorine in the bleaching powder. In all these experiments, you have used internal indicator, but in this experiment, you are using an external indicator called potassium ferricyanide to determine the iron content in the given sample by redox titration. Let us see what is the theory and the principle of this experiment. This experiment is based on the principle of redox titration. What is redox titration? So in redox titration, mainly you will come across simultaneous oxidation and reductions taking place, right? So a redox titration involves simultaneous oxidation and reduction of reactants under suitable conditions. In this particular experiment, you will take more salt solution and you will add H2SO4 and you will titrate against potassium dichromate. So here potassium dichromate oxidizes the ferrous sulfate present in the more salt into ferric sulfate in presence of acidic medium. At the same time, the K2Cr2O7, that is Cr3 plus, will be reduced to Cr6 plus is reduced to Cr3 plus. The completion of the reaction is determined with the help of an external indicator, that is potassium ferricyanide. Let us look into the reactions. Just now I told that you will take more salt solution, to that you will add H2SO4, then you will titrate that again as potassium dichromate solution. So when you titrate the more salt solution again as potassium dichromate solution, what happens? The ferrous that is present in the more salt solution is oxidized to ferric. At the same time, the Cr6 plus, 6 plus, that will be reduced to Cr3 plus. So here Fe2 plus to Fe3 plus, oxidation is taking place. Cr6 plus, that is reduced to Cr3 plus. That is both oxidation and reduction taking place simultaneously. And the overall reaction is Cr2O72 minus plus 14H plus 6Fe2 plus, that gives 6Fe3 plus 7H2O and 2Cr3 plus. So here, what is the reaction with the indicator? So we are using external indicator potassium ferricyanide. So when it come across with the ferrous, what will happen? Ferroferricyanide complex will be formed. That will have a bluish green color complex. So in your conical flask, you will have a more salt solution, and you are titrating against K2Cr2O7 and the reaction mixture. So see what happens here. The ferrous will be oxidized to ferric. When all the ferrous is oxidized to ferric, then you won't get this ferroferricyanide complex, and that will be the end point. Let us look into the procedure part of this experiment. What is the procedure? Number one, part A, preparation of standard solution of potassium dichromate. Weigh out the given sample of potassium dichromate crystals into a clean 250 ml standard flask and dissolve the crystals in little distilled water and make up the solution exactly to the mark with distilled water and mix well. So here you have to weigh out requisite sample of potassium dichromate. Then you have to transfer that into 250 ml standard flask with the help of a funnel. Then you have to add a little bit of distilled water. You thoroughly mix this, and the potassium dichromate crystals that will dissolve. And after this, you make up the solution exactly to the mark with the distilled water, and again you mix it well, right? This is your standard solution. Now what is the concentration of this standard solution? So for that you have to calculate the normality of K2Cr2O7. How will you calculate the normality of K2Cr2O7? You know the weight which you have weight, and you have transferred that into 250 ml standard flask. So for that reason you have to multiply that by 4 divided by equivalent weight. So normality is equal to W into 4 divided by 49.03. You will get the value that is Y. So right, this is your normality of the K2Cr2O7 solution that you have prepared. Next one is estimation of iron in the given solution of more salt. So here the procedure is, again it is very simple. The first is you have to pipette out 25 ml of more solution into a conical flask. Next you have to add half a test tube of dilute H2SO4. Then you have to titrate this reaction mixture against standard potassium dichromate till the reaction mixture fails to give any blue or green color with the potassium ferricyanide. What does it mean? When a drop of reaction mixture is brought in contact with the external indicator, which is taken on a paraffin paper, you shouldn't get any blue or green color. So then that will be the end point. Now you note down how much volume of K2Cr2O7 consumed, that is VML, and you have to repeat the titration till the agreeing values, till you get the agreeing values, right? So, so that is, again, say in burette, you are taking K2Cr2O7 solution. In conical flask, you are taking 25 ml of more solution plus half a test tube of diluted test 4. Indicator, that is potassium ferricyanide. End point is disappearance of the Persian blue color, right? So let us see how this experiment is done. See, it is very easy to say we have taken external indicator and you have to stop the reaction when you don't get the Persian blue color. See, you are not adding any indicator into the conical flask. So, right, you are conducting this experiment with the help of external indicator. So, for that, what all the preparations we have to make? First is, as I told, first you have to in conical flask you have to pipette out 25 ml of more solution, and you have to add half a test tube of dilute HSO4, right? Next, in burette you have to fill the K2Cr2O7 solution. So then indicator, that is potassium ferricyanide, you have to take this potassium ferricyanide, these are the droplets of the potassium ferricyanide, in a paraffin sheet, right? Paraffin sheet. So before starting the experiment, so you have to make some arrangement. You have to take a beaker, right? Beaker. In that you put distilled water, and you have to take a test tube. So there also you will put distilled water. So then you place a glass rod here, right? That is glass rod. This is all distilled water. And in conical flask, you have taken reaction mixture. Conical flask, you will have reaction mixture, right? And in burette, you have what? You will have K2Cr2O7, right? K2Cr2O7 solution. right? So this is this in conical flask. You have taken the reaction mixture, that is nothing but 25 ml of more salt solution plus half a test tube of H2SO4. In burette you have taken K2Cr2O7, and other than that you have taken a beaker. There you have put the distilled water, and inside the beaker you have put the test tube. There also you put the distilled water, and inside the test tube you have put the glass rod, right? So now in the paraffin sheet, you put the potassium ferricyanide indicator in the form of droplets. So this is the arrangement to do this particular experiment. Now what you have to do, you have taken out 25 ml of more salt and half a test tube of H2S4 in conical flask, right? You have not added any indicator into the conical flask, right? Instead of that, you have put the indicator on a paraffin sheet in the droplets form, right? So now what you have to do, you have to add K2Cr2O7 from the burette to the conical flask. So then what happens? The reaction will take place. Fe2 plus, which is present in the more salt, that will be oxidized to Fe, Fe2 plus, that is ferrous is oxidized to ferric, and the Cr6 plus is reduced to Cr3 plus. The reaction is taking place. So now whether the reaction is completed or not, we don't know, isn't it? So we have added just 5 ml of K2Cr2O7 from the burette. After adding the 5 ml of K2Cr2O7, so what you have to do is you have to take out this glass rod and wipe that with a tissue paper. So that means a dry glass rod. You have, with the help of the dry glass rod, you have to take out a drop of reaction mixture and put it on the indicator. So when you put it on the indicator, you will get the Persian blue color. So this Persian blue color indicates the is nothing but the ferroferricyanide complex. That means ferrous is still present in the conical flask, so that this ferrous is reacted with the ferricyanide. So for that reason, you are getting the Persian blue color. That means reaction is not completed, right? Now again you add another 5 ml of uh, another 5 ml of K2Cr2O7 into the beaker. So now it has become totally 10 ml you have added. So now you wash the glass rod with the distilled water, and again you wipe out this glass rod with the tissue paper, and with the help of the glass rod, you take out the reaction mixture from the conical flask and put it on the indicator. Again you will get the Persian blue color. That means still ferrous is present. That means reaction is not completed. So you have to add the K2Cr2O7 still. So again, you add another 5 ml of K2Cr2O7 into the conical flask. So now how much ml you have added? That is 15 ml. So then you may thoroughly mix that reaction mixture. Then again, you take out the glass rod, and before that glass rod should be thoroughly washed with distilled water, and it should be wiped with tissue paper. This dry glass rod, with the help of dry glass rod, again you take out a drop of reaction mixture from the conical flask, put it on the indicator. Again you will get the blue color, Persian blue color. That means still ferrous ions are present in the conical flask. That means complete oxidation of ferrous into ferric. Complete oxidation of ferrous to ferric not taken place so far. So now the same process is repeated. Again, you add 5 ml of K2Cr2O7 into the conical flask. So, and thoroughly mix that. And with the help of the dry glass rod, you take out the drop of reaction mixture, put it on the indicator. So now here you just see there is no formation of the Persian blue color. So still you may get the tinges of the potassium dichromate. What does it mean? So that means your end point may be in between 15 and 20. 15 and 20, right? So that means the amount of K2Cr2O7 that is required for 25 ml of more salt solution may be in between 15 to 20. We don't know whether it may be 16, 17, 18, 19, even 20. But we found the range that is in between 15 to 20. right? Now throw the reaction mixture, everything. Again, you pipette out. Second trial, again you pipette out 25 ml of more solution, add a half a test tube of dilute H2SO4. That will become your reaction mixture. So now you know that up to 15 ferrous contents will be there, isn't it? So then what you can do is you can add up to 15 the K2CR27 into the conical flask. Then you take out the a drop of reaction mixture with the help of a dry glass rod, put it on the indicator. Let us say this is 15 ml again. So you will get a Persian blue color. So that means still ferrous is present, right? Then again you add 1 ml, that is 1 ml extra, that is total will become 16, right? 16 ml. Then again you check it. So with the help of glass rod, take a reaction, a drop of reaction mixture, put it on the indicator. Again you will get, let us say uh, blue color. That means still ferrous is present, right? So still complete oxidation is not taken place. So again, you add 1 ml of K2CR27 to the reaction mixture, thoroughly mix it, take out a reaction mixture drop of a reaction mixture with the help of a dry glass rod and put it on the indicator. Put it on the indicator, that is 17 ml. So that means still you will get the blue color, blue color, that indicates ferrous is present, right? Then again you add 1 ml. So now total how much ml you have added? 18, right? 18, right? 18 ml you have added. Now when you take out the reaction mixture and put it on the indicator, there is no tinges of this Persian blue color. That means this indicates your end point is in between 17 and 18, or you can say the amount of K2CR27 that may be required in between 17 and 18, right? So now you throw the reaction mixture, everything, and again the third trial you freshly pipette out 25 ml of more salt solution. To that add a half a test tube of H2SO4. Now that is in the conical flask. From again you fill the burette. You start it from the zero. So now you know that up to 17 the ferrous ions will be present, so that directly you can add 17 ml, 17 ml, 17 ml. So this is 17 ml. You will get a Persian blue color. So then you add zero point 0.1 ml, zero point 0.1 ml, zero point 0.1 ml. So then what will happen? So this will be 17.1, right? 17.1. So then also you will get the, when you put the reaction, a drop of reaction mixture on the indicator, you will get the blue color, that is 17.1. So still ferrous is present. Then again you add zero point 0.1 ml. So then it will become 17.2, 17.2. So then again you will get the Persian blue color, right? 17, after adding 17.2, you have to take out the glass rod, and with the help of glass rod you have to take out the drop of reaction mixture and put it on the indicator. That procedure remains same. So 17.2 also you will get a blue color. That means still ferrous is present. Then again you add zero point 0.1 ml, 1 ml. Now it will become 17.4, 17.4. So at that moment, when you take out the reaction mixture, a drop of reaction mixture, put it on the indicator, there is no change in the color of the indicator. So this is the color of the indicator. There is no change in the color of the indicator, and that will be your end point. That will be your end point. That means 17.4 will be end point. If you want to further confirm this, you add another zero point 0.1 ml, zero point 0.1 ml, then that will become 17.5. So then if you take out the reaction, drop of reaction, put it, drop of reaction mixture and put it on the indicator, you will get the tinges of, tinges of dichromate. So that indicates the previous one will be the end point, that is 17.4. So they is 17.4. So first trial you will find out 15 to 20 range. Second trial you will find out 17 to 18 range, and the third trial you will find out exactly, this is not 17.4, this is 17.3. Exactly 17.3 is the end point. 17.3 3 is the endpoint. This is 17.4. 17.3 is the exact amount of K2Cr2 so when required for the complete oxidation of ferrous to ferric, ferrous to ferric. Right? This is the procedure that we will adapt. Right? Okay, I think you have understood this, and let us move on to the move on. So so here, so for what we did, so first you have found out what is the in what range, or that is 5 ml range, that is 15 to 20. Next 1 ml range, 1 ml range, 1 ml range, that is so let me write. This is, let us say, this is your initial reading 0, and your final reading will be what is the final reading? Final reading will be 20, right? 20. This is 5 ml range. Then again you started with the 0, and here 1 ml range, that is final reading will be 18. So then again you will go, then this is 17.3, that is zero point 0.1 ml range. So after this you can repeat one more trial. So in order to further confirmation, there also you will get 17.3, right? So first is 5 ml range, next 1 ml range, then zero point 0.1 ml range, right? Let me clear this. Okay. So then for further calculation is very simple. You know the normality of the more salt and volume of more salt, that is normality. So you don't know the normality of the more salt. You know the volume of more salt, that is 25 ml. You know the normality of K2Cr27, and you know the volume of K2Cr27, that is, I mean, from the burette reading, you will find out whether it is 17.3 or 17.4, whatever it may be. So then divided by the volume of more salt, that gives you the normality of the more salt. So then amount of iron Fe2 plus in more salt is given by normality of the more salt into equivalent weight. Normality of the more salt into equivalent weight of Fe2 plus, that is 55.85 grams per liter. So you will get so many grams per liter. So the ferrous content in the supplied more salt solution is this much of whatever the value you will get, that much of grams per liter. This is the simple experiment. I hope you have understood this. Thank you very much.